Hello students. Now in this lecture we see theorem 2. So theorem 3 is, if the sequence of real numbers, if the sequence of real numbers that means sequence n is equal to 1 to infinity, is convergent to L, then any subsequence of sequence n is equal to 1 to infinity, is also converges to L. So in this theorem it is said that if sequence is convergent to any number, that is capital L, then any subsequence of that sequence is also convergent to that number capital L. So this is the statement, and we have only statement, not we have to give proof. Next we see theorem 4. This is also only statement. So what is theorem 4? All subsequences of convergent sequence of real numbers converge to the same limit. So this is the statement, that is all subsequences of convergent sequence of real numbers converge to the same limit. That means if there are more than one subsequences, then all the subsequences converge to the same limit. That means limit of the sequence, given sequence. Now we see the definition of bounded sequence. So what is definition of bounded sequence? So a sequence Sn n is equal to 1 to infinity of real numbers is called bounded. Bounded above if there exists a real number capital M such that Sn is less than or equal to capital M for all small n. So this is definition of sequence bounded above. So a sequence of real numbers is called bounded above if there exists a real number capital M such that Sn means nth term of sequence. This nth term of sequence is always less than or equal to that given number M. This is for all n. That means every term in the sequence n is equal to 1 to infinity. Therefore for every term S1, S2 up to S infinity, each term is less than or equal to this given number M. That means this number M is upper bound of all the terms of sequence Sn. So if there is such a number such that every term of the sequence is always less than or equal to M, then that number M is the upper bound of that sequence, or we say that sequence is bounded above. Similarly, we can say that sequence is bounded below. For that we can say that if a sequence Sn n is equal to 1 to infinity of real numbers is called bounded below if there exists a real number capital N such that Sn is greater than or equal to capital N for all n. So similar to above definition, we can say that sequence is bounded below if there exists any number so that each term of that sequence, that is Sn, is always greater than or equal to that number n. That means the n number is a lower limit of that sequence, and a sequence is said to be bounded below if it has a lower limit like n. That means every term of the sequence is always greater than or equal to n. And now from these two definitions we have bounded sequence. So now bounded sequence means sequence is said to be bounded if sequence Sn is n is Sn from n is equal to 1 to infinity. This is said to be bounded if and only if there exists capital M belongs to real number, set of real number R, such that mod of Sn is less than or equal to M for all n. So sequence Sn is said to be bounded if there exists a number M such that modulus of Sn is less than or equal to that number. That means if the sequence has upper limit as well as lower limit, then that sequence is said to be bounded sequence. So you read these definitions and try to understanding it. We see next theorem in next lecture. Thank you.